All right, Matt 2, here we go. We got lesson 4.2.3, inverse trigonometry. All right, so Mr. Green needs to build a wheelchair access ramp for the school auditorium. The ramp needs to rise 3 feet off the ground, okay, in order to follow the state building codes. The angle formed by the ramp on the ground cannot exceed 4.76 degrees. That's a really specific. Mr. Green decides to start the ramp 25 feet away from the building. Is it enough? Okay, so here's what's happening. It said it's got 3 feet off the ground. So there's 3 feet. And it says he's going to start it 25 feet away from the building. Is it 20? Yeah, 25 feet away from the building. So this is the ramp. And it's talking about the angle. The angle needs to be 4.76 degrees, but we don't know if it is, if it's over or if it's under or what. So we actually don't know what this angle is. I'm going to assume this is a 90-degree angle. So what are we looking for? We're looking for this angle so we can compare it to what the angle needs to be. So it can't be over 4.76 degrees. So we're kind of stuck a little bit. We do have opposite and adjacent. This is the hypotenuse, which doesn't really matter right now. So if we set up a trig function, we'd probably use tangent since we have opposite and adjacent. So we would do tangent of that angle, theta. We just usually use theta when we don't know the angle measurement. It's like a variable for angles. Would be equal to 3 over 25. So the tangent of theta equals 3 over 25. So this is different from a lot of the problems we've seen before because usually we know the angles and we're looking for the sides. Now we know the sides and we're looking for the angles. So it's kind of like going backwards. Well, in math, everything kind of has an opposite. Addition, subtraction, they're opposites of each other. They kind of undo each other. We've got multiplication, division, they undo each other. Squaring and square rooting, they undo each other. Well, tangent, sine, and cosine all have opposites. They're called the inverse. And they've been on your calculator all along. So here I see tangent on my calculator. You might be able to not be able to see that because some kid colored in the tangent on my calculator. So there's tangent, but right above it, it says tan and then to the -1 power. That's the inverse tangent. So in order to solve this one, we need to use the inverse tangent. So if I'm looking for theta, I would take the inverse tangent of 3 over 25. It's like undoing tangent to find that angle. So what you're going to do on, especially on a calculator like this, you're going to hit second, so that green button, and then right up above tangent is tan -1 right there. So second tangent. So now you can see it says tangent -1, which means we're doing the inverse tangent. And then 3 divided by 25. I find out that my angle is 6.84 degrees. So that angle is approximately 6.84 degrees. So the inverse tangent finds the angles. Tangent, sine, and cosine finds the sides. Inverse tangent finds the angles. All right. So at least how far from the building must a ramp start in order to meet the building code? All right, so this is over the code because it exceeds 4.76. So how far from the building should the ramp be? Well, if this is 3 feet and we want to know how far the ramp should be, it should have an angle of 4.76 degrees. So now we can actually use tangent to solve this one. We don't need inverse tangent because we're plugging in 4.76 equals 3 over x, opposite over adjacent. We got x in the denominator, so we exchange our extremes. x would be equal to 3 over the tangent of 4.76. And let's see, 3 divided by tangent 4.76. It looks like we need to be about 36 feet away instead of 25 feet away like we did right here. So the distance away should have been about 36 feet instead. All right. Now we're going to use inverse tangent. We're going to find the measurement of angle A and the measurement of angle B. So let's start with A. So if I'm looking for theta there, this is the adjacent leg, this is the opposite leg, and this is the hypotenuse. So katoa. So we've got adjacent and hypotenuse, that's ka, so cosine. So we would write the cosine of theta, or the cosine of angle A, whichever way you want to do it, would be equal to the adjacent over the hypotenuse, 14 over 15. So if I want to find the angle, I use the inverse. Cosine is for sides, inverse cosine is for angles. So I would do theta is equal to the inverse cosine of 14 over 15. And that's what I'm going to plug into my calculator. So second cosine, so inverse cosine, of 14 divided by 15. We get 21.0394, blah, blah, blah. Let's just call it 21. So we're going to round that to 21. All right, so now we know that the measurement of angle A is about 21 degrees. Now, I could find angle B and use sine, because we've got opposite over hypotenuse, if this is the angle that we're looking at. Or, I already know that these two angles add up to 90 degrees. So I can just take 90, subtract the 21, and that's going to give me angle B. So we get 69 degrees for angle B. Like I said again, if we're looking for this angle up here, we could have done opposite over hypotenuse, which is sine, so katoa. So that's sine. Or, since I already know angle A, I know that these two angles have to add up to 90 degrees. All right. Let's do these three problems. Okay, solve for theta on these ones. So this is the opposite side, this is the adjacent side, this is the hypotenuse. So katoa. So this is cosine, because we got adjacent and hypotenuse. So we would say that the cosine of theta would be equal to 12 over 24. So to find the angle measurement, I would use the inverse cosine of 12 over 24. So second cosine, so it's inverse cosine because it's -1, and I do 12 divided by 24. 60 degrees. So I get that that angle is exactly 60 degrees. Next one. Oh, I already know the answer to this one. See how this is 8 and 8? That's going to be 45 degrees. But anyways, we'll work it out the way we're supposed to. Opposite, adjacent, hypotenuse. So opposite and adjacent, that's tangent. So I should use tangent of theta is equal to 8 over 8. So theta would be equal to the inverse tangent of 8 over 8. Because anytime I'm looking for an angle, I use the inverse. So second tangent, 8 divided by 8 equals 45. See, knew it already. So 45 degrees. All right, next one. We've got, this is the opposite leg, this is the adjacent leg, and this is the hypotenuse. So opposite and hypotenuse, so katoa, that's the so part. So that would be the sine. Sine of 57 is equal to 7 over x. There's not a lot of room for that one. So we would exchange the extremes, and we get x is equal to 7 over sine of 57. So I'm not using the inverse sign on this one because I already know the angle. We only use inverse when we're looking for the angle. So this ends up being approximately, let's see, 7 divided by sine of 57, 8.3465. Let's just call it 8.3. All right. Last problem. Peter can't figure out what he did wrong. Oh no. He wrote down the question below, but his calculator is giving him an error message. So he wrote this down, so it looks like he probably tried to do theta equals, since he's looking for the angle, he would have used the inverse cosine of 8 over 2.736. Let's see what the calculator tells me happens with that one. So second cosine 8 divided by 2.736. All right, so it says domain error. So if it says domain error, it doesn't mean your calculator is broken. It means what you're entering into your calculator is broken. You can't enter the cosine, the inverse cosine of 8 over 2.736. Let's see why. If I've got a right triangle, okay, let's pretend that theta is this one. Okay, cosine is adjacent over the hypotenuse. So this would be adjacent. This would be the hypotenuse. Do you see what's wrong here? The hypotenuse is the longest side. It can't be 2.736 if this is 8. He probably switched the hypotenuse and the adjacent when he set up his equation. Okay, so that's why it's giving me an error message. It's impossible for the leg, for the adjacent. The adjacent can't be bigger than the hypotenuse. That's not possible. The hypotenuse is always the biggest number. So his error is he probably accidentally flipped these two numbers. It probably should have been 2.736 over 8 instead. So if you get that domain error, you probably set up your equation incorrectly. All right, that's all I got for you. Math hard. See you later. Bye-bye.